So in Chapter 2, Section 3, we get into some related rates. And so looking at number 2, we have this function, 1 over root x. So I want to graph this function. So the function is 1 over the square root of x. So we can see what it looks like. So that's an easy matchup. So it look like this one. And then it says find the average rate of change. So this is an x value. It's not a point. So these are from 9 to 36. What's the average rate of change over this interval? So we could do that pretty easily because we're looking at the change in y over the change in x. So again, that's just kind of like your slope formula, y2 minus y1 all over x2 minus x1. So if I want to do that, I could do f of 36 minus f of 9. So I subtract my y values, and I divide all of that by the difference of the x values. So 36 minus 9. And I get this number here. Well, this number, notice that they just give us fraction form. So it's looking for a fraction. So what we could do is, we know f of 36 is, if we plug in 36 into this, we get 1/6. And then we're subtracting, if we plug in 9 here, we get 1/3. And then we have all of this divided by 36 minus 9, which is 27. Right, so we get the same answer, but they want the fraction answer. And so I don't know if there's a magic way on Desmos to convert, but if you have a calculator, a lot of times you can plug in your decimal numbers and it'll give you a fraction. I would probably just go ahead and do the math and say 1/6 minus 1/3, which 1/3 is the same as 2/6, is negative 1/6 all over 27, which gives me that negative 1 over 162. So again, make sure you give the fraction answer, just showing you all that these are equivalent to each other. These decimal numbers are all equivalent to each other. Just have to do the arithmetic. Now, so again, the average rate of change is just finding the slope between 2 points, because it gave us f of 36 and f of 9. And now they're being more specific. So compare this rate with the instantaneous rate of change at the endpoints. So what is the derivative of my function? So we could find the derivative of 1 over root x by saying that's the same thing as x raised to the negative 1/2, right? Notice that this is the same line as what we had before. Those are equivalent things. So it's just using our rules with rational exponents, and it's in the denominator, so if we bring it up top, you make it negative. And so we need to find the derivative of this function. So again, that's using a power rule from that previous section. And so the derivative is negative 1/2, and then we subtract 1 from the exponent. So negative 1/2 minus 1 should be negative 3/2. So this is our derivative right here. And now we're just plugging in 36 and we're plugging in 9 into this problem. So we plug in 36 over here, and then we plug in 9, and that's going to give us those values. So this one is finding a slope, and this one is finding a slope at a particular point. Another one I want to look at is number 5. So here it gives us a marginal cost. And so the marginal cost, when you see marginal, that means we're looking for a way to find the slope at a particular point. And so on this one, we're just going to find the derivative. So we would distribute, and then we'd have, on this particular problem, I think we'd have 900 plus 900, and I'm going to go ahead and say x raised to 1/2. Whenever I see these roots, I'm going to change it to x to 1/2. And so now if we're taking the derivative of a constant is 0, and the derivative of this piece, 1/2 times 900, is that 450, and then we subtract 1 from our exponent and we get that negative 1/2, or we could put it in the denominator. I'm pretty sure WebAssign would let us do it like that, and that would be fine. Those are equivalent expressions. And then lastly, looking at number 6, so find the additional revenue when the number of rentals is increased from 14 to 15. So if this is a revenue equation, I would plug in 14. So let's actually do that. Let's get rid of all this. If I have my revenue equation, so 6x times 600 plus 40x minus x squared, and if I evaluate it at 14, I get that value. If I evaluate it at 15, I get that value. So my difference is between my x values, the number of units I'm looking at. Number of rentals is my unit. The difference is that. So it goes from 80,976 to 87,750. If I actually subtract those numbers, that gives me the amount of additional revenue. So R15 minus R14, I get 6,774. That's the difference in the unions. Now the marginal revenue, that tells me what my my slope is at 14. So that means I'm going to take the derivative of this function. So again, you would expand this, take the derivative, and then plug in 14 in your derivative. And that's how you would get the 6792. So when you see marginal, take the derivative, plug it in. If it's asking for a rate of change, that means the slope between 2 points. In this case, we were looking at the slope from a difference of 1 unit, right? 1 rental unit. And on this case, it would just be the difference of those two. So additional revenue or rate of change, like on this problem up here, the average rate of change, that's finding a slope between 2 points. Or if you're finding a marginal value, like on 5 or 6, that means you take the derivative of the function and then you plug in, you want to find the slope at a particular value, like 14.